We know in a covalent bond, valence electrons are shared. So if we take, for instance, fluorine. Fluorine has 7 valence electrons, which is why it's easy for it to share. Remember, only the nonmetals are sharing these valence electrons. Metals give them away. So if I have 2 fluorine atoms, they each have 7 valence electrons. They would each very much like to have one more. So if I look at these 2 fluorine atoms, these 2 electrons, these unpaired electrons on each atom, they can form a bond and they can share. Now this right here allows me, these electron dot diagrams allows me to figure out how they're sharing, but there's actually a scientific way of writing this. We write a structural formula that shows the bond, and to draw a bond we use a line. So we have a bond between 2 fluorine atoms. And that looks like this. You'll notice I still put my electrons here that are not involved in the bond because fluorine obeys the octet rule, and when I'm done drawing this I should be able to check myself, see if I did it right by making sure everything has 8 valence electrons. So 2, 4, 6. This line counts as a pair of shared electrons, so it's 8 because a shared electron gets counted for both. And so 2, 4, 6, 8. Both of those fluorine atoms have 8 valence electrons. That's a stable, happy molecule. It's F2. This is just fluorine. Now this right here is called a single bond because it's only got one pair of shared electrons. One electron is being shared from each atom. Okay, so they have one single bond between them. Now if we look at oxygen, say, another one of those diatomic molecules, oxygen has 6 valence electrons. And the reason when you're drawing electron dot diagrams that you draw every side with 1 before any side gets 2 is because unpaired electrons are the ones that form bonds. So right here I can see this pair of electrons is going to form a bond and this pair of electrons is going to form a bond. But these two won't because they're already in a pair. These two won't because they're already in a pair. So unpaired electrons form bonds. Again, I'm going to rewrite this using the structural formula. So oxygen double bonded this time to another oxygen. So there's 2 pairs of shared electrons, so I have 2 lines, one for each pair of electrons. And of course, I still have my other valence electrons that did not get involved in the bonding. And when I sum up this rule, or make sure they're following the octet rule, I have 2, 4, 6, 8. These lines count for both, 2, 4, 6, 8. So they both have 8 valence electrons, they're both stable. I have O2. Okay, that's oxygen, that's fluorine. And finally, another one of those diatomic molecules is nitrogen. Now nitrogen is a group 5 element, which means it has 5 valence electrons. Okay? So if I had 2 nitrogen atoms, they each have their 5 valence electrons, and we can see that every unpaired electron has a place to form a bond. There's 1, there's 2, and there's 3. Okay. Again, the structural formula says, well, let's replace those circled pairs with actual lines that show the bond. Okay, so there's the 3 bonds between 2 nitrogen atoms, and then they each have their pair that did not bond. So 2, 4, 6, 8. Again, we're obeying the octet rule. This thing right here, that's called the structural formula, and it tells me how the bonds work between 2 different atoms, or maybe more than 2 different atoms. For instance, let's take a look. So these are all elements, right? Fluorine's bonded to fluorine, oxygen's bonded to oxygen, nitrogen's bonded to nitrogen. So this is fluorine, this is oxygen. Right? There's no special names here. This is nitrogen because I don't have 2 different elements. It's not a compound. I have the same elements. It's just an element. Okay? But if we go to something like water, okay, water has the chemical name dihydrogen for 2 hydrogens, monoxide. Mon meaning 1, oxide referring to oxygen. So this is H2O. That's the chemical formula. I want the structural formula. I want to know about the bonds that actually happen in here. Okay, so what I'm going to start with is the electron dot diagrams. Oxygen is a group 6 element. It has 6 valence electrons. Hydrogen, remember, is a group 1 element. It has 1 valence electron, but hydrogen doesn't obey the octet rule. Hydrogen only wants to have 2 valence electrons because it only has to fill the first energy level. So I can see hydrogen can make a single bond with oxygen. That's why it's H2. We need another hydrogen over here to make another single bond with oxygen. And so what we get out of this is oxygen single bonded to hydrogen with its 2 pairs of unshared electrons. So 2, 4, 6, 8 for oxygen and 2 for hydrogen, 2 for hydrogen. So everything here is stable. This structural formula shows us how these things are put together. Another example real quick, let's take a look at carbon dioxide. Okay? Again, you have the name that tells you what the chemical formula should be. Carbon has no prefix on it. Since it's the first one, we know that means there's one atom of carbon. Di means two. Oxide, again, refers to oxygen. So CO2 is carbon dioxide. And then, structural formula. Well, again, I'm going to start with my electron dot diagrams. Carbon is a group 4 element, 4A, so it has 4 valence electrons. Oxygen, again, still has 6 valence electrons. So I can see oxygen can make 2 bonds, carbon can make 4 bonds. I need 2 oxygen atoms. So basically, this electron can pair up and this electron can pair up. Now, I would never draw this for a final thing. That's just letting me, oh yeah, those two things bond. So I can see I'm going to have a double bond between carbon and oxygen. So I'm going to draw that double bond between carbon and oxygen, and then carbon's still got these 2 electrons to make another double bond with another oxygen. Oxygen has those 2 pairs that did not form bonds, and if we got to make sure the octet rule is followed. So 2, 4, 6, 8, 2, 4, 6, 8. 2, 4, 6, 8. Every atom here has 8 valence electrons. Remember, those bonds count for each atom that is bonded. So when you're drawing structural formulas, start with electron dot diagrams to figure out how many bonds each one is making, and then make sure they obey the octet rule unless it's hydrogen, which of course only needs 2.